Hello, my amazing students. This is Mrs. A, and I am back with lesson 67 in your Saxon Orange Book. And we are on review of equivalent equations and elimination. So we're solving systems of equations. Now remember that two equations that are equivalent have the same solution. Okay, so same solutions means equivalent equations. And the solution sets have to be identical. So let's look at these two equations. Now, if I look at this equation, I can tell that x could be 2. And there's really nothing else that x could be. So the solution set to this one is 2. I look over here, 2 squared minus 4 is 0. So this one also has a solution set of 2. Now, does that mean that the two equations are equivalent? The answer is no, because this one has an additional solution. -2 would also make this one true. Let's check it. -2 times -2 is 4. 4 take away 4 is 0. So this one is what we call quadratic because it has an x squared and it has 2 solutions because it has an x squared. Okay, so if we have an x squared equation, we expect 2 solutions. But when we have something like this, there's just x to the first power, we expect 1 solution. That's kind of an easy hint, isn't it? So these two are not equivalent equations because they do not have the exact same solution set. Okay, what about two equations like this? We have x plus y is 6. 2x plus 2y is 12. Now we know we have a property. It's called the multiplication property of equality. And that multiplication property of equality tells us that if we have an equation and we multiply both sides of the equation by the same non-zero number, then we get another equation that is exactly identical to the first equation. So we multiplied x by 2 and y by 2 and 6 by 2. So we multiplied both sides of the equation by 2. So these two equations should be equivalent. Well, let's check. Let's see. Now, x plus y is equal to 6. Since there are 2 variables, there are an infinite number of solutions for this equation. Now, what do I mean by infinite? Well, I can put, because I have both positive and negative numbers available to me, if I say 55 plus something equals 6, can I come up with a y that will make that true? I can. So 55 plus, now we're going to get to 6, so we're going to say a negative, what, 49? 55 plus a negative 49 equals 6. And it does, doesn't it? All right, so let's take that really weird solution and let's go up here. Is twice 55 plus twice negative 49 also equal to 12? Okay, so 55 times 2 is 110 plus 2 times negative 49 is going to be negative 98. And when I add those two together, I do get 12, don't I? So I can come up with an infinite number of solutions, and those same solutions work into this one. Okay? Now, we normally wouldn't do that. We might say 4 plus 2 is 6. That's another solution, maybe one that your mind would go to a little faster. And then 4 plus 2 is 6, but if I put a 4 here and I put a 2 here, I get 8 plus 4 is 12. And that's true also. Okay, so whatever makes the first one true should also make the second one true, because the second one is just a multiple of the first one. It's the first one multiplied by 2 on both sides. You might ask me, what on earth does that have to do with elimination? But when we have an equation and we multiply it by a constant number on both sides, we get an equivalent equation, and we're going to be looking at that as a method of eliminating. Now, this problem does not need much help for elimination. This is a system of equations. When I say a system of equations, that means hopefully, usually, when we're trying to solve a system of equations, we don't expect these two equations to be equivalent to each other. If two equations were equivalent, then the system of equations would have an infinite number of solutions because they're actually the same line. Okay, like we just saw with 2x plus 2y equals 12. But before we go with this, let's talk about 3 types of systems of equations. Okay, now these two equations do not look like they're the same line. Okay, so if this one was multiplied by -1, I'd get -2y, but that's not multiplied by -1, and that's not multiplied by -1. So they do not look like they're the same line. Okay, we have 3 types of systems of equations. We have systems of equations that are what we call independent lines, and they cross in one point. Okay, we have systems that are 2 parallel lines. That does not look very parallel, does it? 2 parallel lines, and they would never ever cross. We call this system inconsistent. And then we have a situation where the 2 lines are actually the same line. Okay, and we would call this consistent dependent, meaning it has solutions, an infinite number, and they're the same line. Dependent means the same line. These would be inconsistent independent because they're not the same line. Inconsistent means they'll never, ever, ever cross. And this one is independent because they're 2 different lines. Consistent because they have one solution. Now, you don't need to know that right now because that's not in this section, but we're going to keep on reviewing that because knowing the 3 types of systems of equations is important. It's just not in this lesson. Okay, but I wanted you to kind of get an idea. So when we're trying to solve a system of equations, we're usually looking for that point right there. We're trying to find out what is the solution point that makes both equations true. All right, so in this system that we have up here, we have a 2y and a -2y. So this one is all set up for elimination. When I say elimination, I mean getting rid of one of the variables. What if I just add the 2 lines together, just like they are right now? X is really 1x, isn't it? 1x plus 5x is 6x. 2y minus 2y, or plus a -2y, is just 0. So these are going to cancel and go out. 8 plus 4 is 12. No more y. I'm ready to solve for x. 6x is 12. If I divide by 6 and I divide by 6, doesn't that mean that x must be equal to 2? All right? If x is equal to 2, then remember we're looking at this kind of system. That little point right there. That little point right there is labeled as an ordered pair 2 comma something. We don't know what the something is yet, do we? To find that out, we're going to go back up to one of the equations. Okay, so x is 2. I'm going to put a 2 right there. 2 plus 2y is 8. Now the y's are coming back. I'm going back to my original equation. 2 plus 2y is 8. If I subtracted 2 and subtracted 2, then I get 2y is 6. If 2y is 6, then isn't y equal to 3? So now I've solved for the y value of the ordered pair, which is the intersection point. So now I need to check. Notice I didn't just touch this line. I used this line, not this one. I'm going to go back and I'm going to plug them both into this line. So x and 3. 10 minus 6 is 4. And that's true. Therefore, we have verified that 2, 3 is the point, the ordered pair, that solves both equations. And therefore, it is the point at which the two lines cross. And it is the solution of the system of equations. Okay, so now we have another system of equations. This one's not quite as pretty as the last one was. The last one we had a 2y and a negative 2y, so all we had to do was add the two lines together. But here we've got a 2x and a 3x. We've got a negative y and a positive 4y. Nothing really goes together to eliminate right now. But we can make them eliminate by saying, okay, what do I want to multiply by to get something to cancel out? Okay, now I'm going to multiply this top line by 4 all the way across. Okay, now just to make things easier, I'm going to take this and just stick it right down here. 4 times 2x is 8x. 4 times a negative y is a negative 4y. And 4 times a 13 is going to be a 52. Okay, so now wouldn't you agree that these two equations here are now equivalent, because this equation is simply this equation multiplied by 4 on both sides. So now we're going to get rid of this one temporarily. Okay, I'm going to cross it out just temporarily. We're going to play with these two. Now, if I add them together, will one of them eliminate? So 4y and negative 4y, poof, those go out. 3x plus 8x is 11x equals 3 plus 52 is 55. 11 goes into 55 evenly. 55 divided by 11 is 5. So x is 5. So the x part of the ordered pair is 5. Now, we're going to take that 5 and go back up into one of the original equations. So, I'm going to bring this guy back. Okay, because it's always easier to work with the original equation, most often. Sometimes if it has fractions, I might skip that step. But we're going to put the 5 right here. And we're going to figure out what the y is that goes with it. So I have 2 times 5 is 10 minus something is 13. Well, 13's bigger. So I'm minusing a negative number, and the negative number is 3. So we're going to say y is negative 3. 10 minus a negative 3 is 13, isn't it? Okay, so now I've got my ordered pair. I'm going to now check it using this original line. Okay, so the x goes here where the x is. The y goes here, and it's a negative 3. So we get 15, take away 12 is 3. And that is true. Therefore, 5, negative 3 is the ordered pair solution of the system of equations. And that, my friends, is elimination. When we're trying to get one of our variables to poof, disappear. Okay, so here we're going to do the same problem 2 different ways. This one is not cooperating very well. 2x and 3x, 3y, 4y, nothing that we can just multiply one of them by to get it to equal the other, right? So what we're going to do is we're going to end up multiplying both equations by something to get, first we're going to eliminate the x's. So we want to get rid of the x's. So we're going to say, what is the number that both 2 and 3 divide into evenly? In other words, what is the least common multiple of 2 and 3? And the answer is 6. So what I'm going to try to do is get one of these to go to positive 6x and the other one go to negative 6x. Okay, so if I'm going to put the positive on the top, then I'd make this one a positive 6x. So I'm going to multiply the top line by 3 all the way across. So I'm going to multiply this one all the way across by 3, and then this one all the way across. If I want that to be a negative 6x, so that when I add them they eliminate, then I want to multiply by a negative 2. Okay, so I'm going to multiply this one by 3 and this one by a negative 2. Now in your book, they multiplied this one by a negative 3 and this one by a positive 2. Does it matter which one was negative and which one? No, it doesn't. Okay, but in the next time we do this, we're going to eliminate the y's instead of the x's. Okay, so we're going to take 2x and multiply it by 3 and get 6x. Negative 3y times 3 is negative 9y equals 5 times 3 is 15. And then 3x times a negative 2 is negative 6x. And a 4y times a negative 2 is a negative 8y equals negative 18 times a negative 2 is a positive 36. Do you see how my x's are all ready to eliminate? 6x and a negative 6x, poof, disappears. Negative 9 and a negative 8 gives me a negative 17. Y equals 15 plus 36 is 51. Okay, well, thankfully, 51 divided by 7 is exactly 3, but it's a negative 3, right? So we're going to get y is negative 3. So now we're going to take the negative 3. We're going to go back up into one of those equations, and I usually will dump it into the first equation. So y is negative 3. So now we have 2x plus 9 is 5. So doesn't that mean that 2x must be, if that's positive 9, doesn't this need to be negative 4? So if this is negative 4, plus 9, that would give me a 5, wouldn't it? So 2x is negative 4. That means that x is negative 2. Okay, so now we're going to go in the second equation and check both of these. So x is negative 2, y is negative 3, negative 6 minus 12 is negative 18, and it works. So we get our solution is negative 2, negative 3. So let's just write this up here. Negative 2, negative 3. Now, we solved it once by eliminating the x's. Now, we're going to eliminate the y's. We're going to take the exact same system of equations. We're going to take these out because starting with those there, that would be cheating. Okay, we're going to go back to, this is just a 2x. And this one was a 3x. And now we're going to eliminate the y's instead of the x's. All right, so that means all of this is going to go away. And we're going to see that we can work the problem an entirely different way and still get the same answer. Okay, now we're going to eliminate the y's. So here we're going to look at Ooh, this is cool. They're already opposite signs, aren't they? We have a negative and a positive. But their least common multiple is 12, right? 3 goes into 12 and 4 goes into 12. So I want this to be 12. I want this one to be negative 12 and this one to be positive 12. So what will I multiply this line by if I want this to be a negative 12? Wouldn't I multiply this whole thing by 4? Got to get rid of that one, don't we? Okay, so we have a little bit more room here. I'm going to put the 4 right on the front. And I'm going to put the one that I'm going to multiply this one by right there. So 4 is going to multiply, but then this one needs to be 12, positive 12. So I'm going to multiply this equation by 3 to eliminate the y's. Are you ready? So 4 times 2x is 8x. 4 times a negative 3y is a negative 12y. And 4 times 5 is 20. Then we do the second equation. 3 times 3x is 9x. 3 times 4y is 12y. 3 times a negative 18. 3 times 8 is 24. Carry the 2, negative 54. Notice we have a negative and a positive 12y. Those are going to cancel. And we get a 17x equals 20 minus 54 is a negative 34. And negative 34 divided by 7 is a negative 2. Okay, so negative 2 plugged back in up here is going to give me the same thing. But haven't we already finished what we wanted to do? We wanted to show we're going to come up with the same solution. Negative 2, negative 2. Okay, so I'm not going to finish this because I'm out of board space, but we did it once, eliminating the x's. We did it a second time, eliminating the y's. Of course, to finish this up, we would take the negative 2, plug it in right here, and come up with that. But we've already done that. We've already done that step of it to get the negative 3. So we'll stop there on that one because we still have more to work. Okay, so here is our last example before we work our practice problems. So we're getting there. Now 2x and 3x, nothing that I can just multiply one thing. Neither can I multiply the 5x and the 4x by just one thing. So I'm going to have to go towards a common multiple. Okay, so I'm going to go ahead and choose to work with the 5 and the 4 and get rid of them. The 5 is already positive and the 4 is already negative. So what if I think 5 and 4 go to 20? That's the least common multiple. So I'm going to multiply this one by 4 to get a positive 20x, and this one by a 5 to get a negative 20. Hold on. I think I copied that wrong. I think that is supposed to be a y. And it is. Okay, so this one by a 5. 5 times negative 4 is negative 20. So now let's go across. 4 times 2x is 8x. 4 times 5 is 20y. 4 times negative 7 is negative 28. 5 times 3x is 15x minus 20y equals 5. 23x cancel equals negative 23. Okay, so 23x is negative 23 doesn't mean x is negative 1. So we found our x. We're going to put our negative 1 right here so that we can find our 5y. Now when I'm doing that, I'm not going to use this one. I'm just going to say, okay, well, I've already done the 4 and I've already done the 5. I'm going to go back to the original equations because they're simpler. So I'm going to put a negative 1, so that makes this a negative 2 plus a 5y is a negative 7. Well, I need this to be a negative 5. So that y is going to be a negative 1. So we're going to say y is negative 1. And we get negative 2 minus 5 is negative 7, and that's true. And now we're going to check those right here. So 3 times a negative 1 and y negative 1. So we end up with a negative 3 plus a 4 is 1, and that is true. So the answer is negative 1 on that one. All right, so we're going to eliminate. This is your practice problem. So I hope you will pause your video and go do it by yourself so you'll know if you know what you're doing. I'm going to take both of these to 12 and one of them to negative 12. I always want them to cancel each other out. So 4 times 3 gives me the 12. So I'm going to multiply this one by 3, which will make that a 12y. And then I'm going to multiply this one, which is a positive. I need a negative. And I'm going to multiply it by 4 so that that will be a negative 12y. Okay, so now that we know what we're going to do, we're going to have 9x plus 12y equals negative 21, just multiplying the 3 all the way across. And now we're going to multiply the negative 4 all the way across. So negative 4 times a 2x is a negative 8x. Negative 4 times a 3y is a negative 12y. Negative 4 times a negative 6 is a positive 24. And when I add, this goes to x. This cancels. And 24, take away 21 is 3. X is 3. Wow, that one was pretty easy. So now I'm going to take the x is 3 right there. I'm going to ignore this. I'm going to ignore this. I want to go back to my easiest equation. I plug in a 3. This gives me a 9. Plus something gives me a negative 7. Okay, well, 9 to negative 7. That's 16 steps backwards, isn't it? So 4 times negative 4. So y is negative 4. Now we're going to check into this equation. So 3, negative 4, 6 minus 12 is negative 6, and that works. Therefore, my answer is confirmed to be 3, negative 4, the ordered pair. Last practice problem. Okay, so nothing's going to really work easily. I'm going to have to multiply both equations by something. I'm going to get rid of the x's this time. And since 2 times 5 is 10, 10 is the smallest, the least common multiple. So we're going to multiply this equation by a 2. And since I want this one to be a negative 10, I'll multiply everything by a negative 5. So 2 times 5 is 10x. 2 times 2y is 4y. 2 times negative 3 is negative 6. Negative 5 times 2 is negative 10x. Negative 5 times 3 is negative 15y. Negative 5 times negative 10 is positive 50. So now we have an elimination right there. 4y minus 15y is negative 11y. And here we have 50 minus 6 is going to be 44. And 44 divided by a negative 11 is y equals negative 4. So we have a y. So we're going to put our y, negative 4. We're going to get rid of those. Go back to our original equation. Okay, so I'm going to erase this because that's no longer needed there. So negative 8. We're supposed to get a negative 3. 5 times something minus 8 is a negative 3. Well, isn't that 5 times 1? 5 take away 8 is negative 3, isn't it? So we're going to say x is 1. And so x is 1 and y is negative 4. So let's check it. X is 1 and y is negative 4. 2 minus 12 is negative 10. And that's correct. So our answer is 1, negative 4. That's the ordered pair that solves that system. And I hope you got the same answer. And it didn't matter. You could have eliminated the y's instead of the x's. I just chose to eliminate the x's, but you could have eliminated the y's, and you should have gotten the same answer. We are done with lesson 67. This is Mrs. A, and may God bless your day.